to the talk, everybody. My talk is called Misconfigured CORS and why being secure isn't getting easier. And it is kind of a talk where I kind of talk about one specific problem and then look at how there's a lot of problems, and it's this one problem, which is misconfigured CORS, has one root problem that is, it's getting really big in the web application security world, and it should be fun because kind of looking at the internet as a whole is fun. About me, my name is Evan. I'm a software engineer, but I work on product security at Cloudflare. And if you're not familiar with what Cloudflare is, it's a giant reverse proxy, giant network, and I don't know what we advertise, but at any time we're doing like 1 billion. Our customers, we're a giant proxy, and we're dealing with over 1 billion requests every like 15 to 20 minutes. So the scale is really big, and we have a lot of customers, millions of sites that use us as a CDN. So it's looking at the internet as a whole is like kind of comes with the job description. And so the first thing is start off with a question, and it's not a good question. It's how would you secure the internet? And it's if anybody knows, like, we can just all go home. Yeah, that'll work. So it's a lofty and idealistic goal, and it's not really attainable because there's core problems, fundamental issues with how the internet works. There's BGP hijacking and route leaks. There's problems with DNS and even TLS, which everybody knows is a good thing, is really bad. Just you rely on every single CA in your trust store to be honest and not issue rogue certificates. And so they're like, this is not something that we can do. And so at work, we want to make the internet secure, though. That's one thing that one of my goals when I go to work is like, how can I improve things for the internet? And so the question shouldn't be how would you secure the internet? It's like, how would you improve the security? How would you make a dent in the internet? How would you help it? And so kind of having a lot of websites on our product, we kind of look at how we can help a lot of small mom and pop shops is usually the end receiver of the work that we do. So like we gave away TLS, and we gave that to all of our customers for free. And so thinking in that realm, how can we make security better for everybody? And I don't know, it's just important when thinking about questions like this to consider, I guess, the little people, just because they're the people on the internet who, like, you go to New York Times, you go to Amazon.com, you go to Facebook.com, and these are secure sites. And your mom and pop shop that you order pizza from, they don't have a security budget. They don't have a web developer probably. And so helping them would drastically, a lot of them would drastically raise the bar. And so this is a castle, and it gets used in security metaphors all the time. Like, we want to build a castle. It's got a strong foundation. It's got lots of walls, and it's big and mature. And that's kind of the Facebook and Google and Amazon and Apple. That's them, and that's not what everybody else has. This is your typical site in the Alexa 1 million, security-wise, and in a lot of other ways, like usability and like there's a famous blog post, The Web Obesity Crisis, talking about how the average page has gone up by many megabytes that you download. Web pages are massive these days because of all the images and everything. And security-wise, it's the same thing. People are installing WordPress plugins that they have no idea what they do. People are just, so I think we all kind of understand how this happens, how security for a lot of these small companies is not comparable to the security for like a Facebook or a Google, where they have invested in hundreds and hundreds of security engineers. So I guess let's start with talking about same origin policy, which is the foundation. If you're a web application security person, you have undoubtedly come across same origin policy. It's the foundation and linchpin of security on the internet. And all it says is, it's not all it says, but example1.com cannot load data from example2.com by default. That would be terrible if it could. That's like the worst thing that can happen on the internet. If this same origin policy thing didn't exist. And, this is, just lost my train of thought. Not everybody wants this. Like some people, you might own example2. Example1.com might be a company that owns example2.com. And so this is, this kind of prompted something which is the subject of my talk, called CORS, Cross-Origin Resource Sharing. And it's, CORS is a way to poke holes in same origin policy and allow this type of communication for example1.com to communicate in your browser with, example2, some other site. And this is kind of what CORS looks like. So example.com requests exampleapi.com, and it might be a little hard to see, but it says under the bottom arrow there's two important headers here. So the top is a HTTP request from example to example API, and it says get. They're getting some info, and the origin header example.com. It says where it's coming from, and then exampleapi.com responds with access control allow origin. And this is the mechanism through which CORS works. It's header based, like everything HTTP. And there are good reasons there's a lot of configurations in CORS, and I'm not going to talk about all of them. There's only one that we really care about, and so the important thing, one of the things that's important to know is CORS is driven by the origin header. If you look here, wrong screen, you see example.com. This is automatically attached to cross-origin requests by the browser, and that's how exampleapi.com knows what headers to return, what CORS headers to return. This access control allow origin header. And so based on the origin header that is in the HTTP request, you get back some policy about cross-origin resource sharing. And the other important thing to know is that star has a special meaning. And you'll notice that in my example here, star is returned. And that means anybody, you're open to the world. Anybody can talk to you. But nobody can send cookies. And that is very important to note, that star means open, allow all. And that kind of, it's important to think of CORS at this point as like a way to poke through same origin policy. And this star thing was meant to do an allow all, but not have developers shoot themselves in the foot by turning off same origin policy. And so this is pretty interesting. So here's a real world CORS header. There's an HTTP request to fetch some Google jQuery library, jQuery.min.js from their Google CDN. And Google says access control allow origin star. So this is open to the world for JavaScript to download this JavaScript and use the JavaScript. And it's star. So no cookies. And this is the other important case that we're about to talk a lot more about. So this is actually Fastly.com. They're a Cloudflare competitor. I only have them on the slide because I knew that they did this on their website. But based on this origin header, www.fastly.com, I'm requesting app.fastly.com, and app.fastly.com says www.fastly.com can communicate with me, and credentials are allowed. So you can pass cookies between these two sites. And that's completely reasonable. This is like exactly what CORS was made to do. But I think that it might not be obvious at first, but using CORS, you can still turn off same origin policy. And there's reflecting all origin headers as access control allow origin, and always saying access control allow credentials true would be really bad. That is defeating the whole point of same origin policy that the people 25 years ago when they were building the web created it for. And so I think I was playing with CORS one day, and I just thought, like, I wonder how many people do this. It seems like something that someone had to have done accidentally, and I wonder how widespread it is. And I thought about this maybe 8 months ago or something, and so I scanned it. I scanned the Alexa 1 million for this problem, and yeah, I already talked about that. And so yeah, so this is why it would be so bad. I don't think I've explained this yet. So turning off same origin policy, if it didn't exist, you'd go log into your bank account, you'd have your bank cookie, then you'd go to an evil website, and your evil website could just like make requests to your bank and steal your bank data. It's trivially easy. And here's the bank has these two headers: access control allow origin evil, access control allow credentials true. And it's if this was real, this would be really bad. It's clearly not real. This is an awful bank. They're returning latitude and longitude information and not banking information. Yeah, so this is what the problem would look like in the real world if it existed. And so testing for it, very easy. I just showed you some curl requests. It's very easy to do. You just add a dash page for the site and add an origin. And curl is great for one request if you're testing one site, but it's not well suited if you're going to scan the Alexa 1 million. So I had to break out some bigger firepower, but curl has been my best friend while doing this research. And here's an example of someone who I got with it. So this is one of the first sites, streamable.com. They're a video, some kind of video, they're fast video provider of like little clips. I've come across them while browsing Reddit a lot. And this got patched at like 11:30 last night. I reported it to the CEO, and he said thanks, and then a couple weeks went by and nothing had changed. So I emailed him again last night, and within like 3 minutes it was fixed. So I guess he just forgot. But yeah, so I had a proof of concept so I exploited it with curl, but then I needed a real exploit to to show how an evil website would do it. And this is it's just like a little bit of JavaScript. Ajax, you send a GET request to Streamable to their API, getting my information, and then I steal the data key, the stream key. That's their like secret Streamable API key. And it's you just have to specify with credentials true. It's even less code. This is jQuery. It's less code. Excuse me. With the new fetch JavaScript API. So it's like trivially easy. You just have to send the HTTP request, and it just works. If someone has misconfigured their and so but how bad is it? How bad is it for everyone else? How bad is it in the Alexa 1 million? Is it a big problem? And the answer is it's a huge problem. Really big. How do I know? So I scanned for it. I sent an origin header with the words myevilsite.com, and then I looked for these two things: access control allow origin myEvilSite and access control allow credentials true. I followed all the redirects that I got and checked both HTTP and HTTPS, and the results were 1,514 sites in the Alexa 1 million had turned off security, which is astounding. It's kind of important to remember, though, that sites that are only serving static content, it's like not really an issue. This is really maybe like 750. It's really a big problem because sites without user data, there's nothing to steal. So, but it's pretty astounding. I'm going to publish the list in a couple weeks. Where I'm just waiting for one of the companies to fix the problem, one specific company, and but yeah, it's a lot of people have this problem, and if even half of these, looking through it, it's like the Alexa 1 million. I'm sure if you've ever looked at it, you maybe recognize the first 20, and then there's stuff you don't recognize. Like once you get down to 200,000, it's like I really don't recognize any of the sites anymore. And so these are high traffic sites, news sites, all sorts of different things all over the world that have turned security off. Which brings up a new problem: is how do you disclose this? Yeah, so the code is on GitHub. It's public right now. It's all Go, and since I'm a big gopher, it's got a lot of slick concurrency patterns that are really nice, which I'll show you really fast. So I basically have this is some Go code. I have one Go routine. You can think of it as a thread. It's not really a thread, but you can think of it as one. And it's just reading file names, reading sites to scan and shoving it into this right here, which is a Golang channel. And then I have, these are a bunch of worker Go routines that are reading from the channel right here and doing a scan. And then the scan just does a HTTP request. And there's some tiny details there that you can check out in the code. Like I turned off SSL verification because who knows if I'm going to get an expired cert. And I did, yeah, and then you have to set the headers. But it's pretty simple. It was less than 80 lines of code, or less than 100 lines of code. Yeah, this is the wrong link. This is the right link. Sorry about that. So, yeah, this brings up a question for me: is what the heck do you do when you find 1,500 problematic configurations on a site? For 1,500 sites with this really problematic configuration, there's not really a mechanism in security for this. You might think like, okay, CVE is what this is for, but it's not. CVE is not well suited for this kind of disclosure. Because it's not in any specific software package. It's not, there's no one place that this problem came from. It came from people misunderstanding how cross-origin resource sharing is supposed to work. So kind of what I did was I went down the list and I hunted for names I recognized, like I looked for .io TLDs because I figured there's going to be startups that have this problem and they're usually very responsive, like the Streamable CEO. They're usually very responsive. Like I emailed the Streamable CEO at 3 in the morning and he got back to me in 2 minutes the first time I emailed him. So that's kind of why I stuck with startups and big companies. And yeah, besides that, I really haven't even looked at the list. It's just really big. Yeah, so this isn't something I can get a CVE for. Like HackerOne has this internet bug bounty thing, but that's not well suited for this because that's also for specific, that'd be like a Heartbleed kind of problem. So there's really nothing in security you can do except disclose. Which is fine, but it might be nice. So I started hunting for where this problem came from, like specific software packages that were introducing this problem. I noticed Sales.js. I've never used this, but it's a Node MVC framework. They kind of make it really easy to make this configuration. There's going to be a Node security bulletin about this released Monday for Sales. Rat CORS is a Ruby gem that makes this. There's a Go library that's pretty popular that does this. There's 2 Go libraries. One of them is good, one is bad. I'm not sure if there's RS CORS. And I want to look at a lot more of these and do more hunting. But yeah, it was fairly easy to start tracking this problem down to the source of what libraries were introducing it. And it's more of them were bad than were good. More CORS libraries that I looked at didn't do the right thing than did. So, which is very scary. But nothing beat my satisfaction compared to this. I thought, where else could this be coming from? And the answer is always Stack Overflow. There's always something wrong on Stack Overflow. So I Googled CORS, like CORS something Stack Overflow, and the very first one was this, PHP, and they are reflecting the origin header for all origins, and they have credentials true turned on. And it looks very official, like there's all this documentation. They have the RFC right here for how CORS work. This is something, it's got 106 upvotes when I saw this and took the screenshot, and last night it had like 140. And so it's just bad information that is getting perpetuated. And yeah, this is still just so funny to me. And the best part about this is a comment on that where this Jules person, shout out to Jules, they perfectly and eloquently explain exactly the problem that this piece of code introduces. And this was that's July 7, 2012. And I'll read it in case it's too small. Note that sending the HTTP origin value back as the allowed origin will allow anyone to send requests to you with cookies, thus potentially stealing a session from a user who logged into your site, then viewed an attacker's page. You either want to send star, which will disallow cookies, thus preventing sessions, or the specific domains for which you want the site to work. And that's better than I could have said it. So shout out to Jules in 2012 for calling this. But I just thought this was hilarious. So what is the point about me and all this ranting about CORS and this specific problem? What is the actual problem here? And the actual problem is just complexity with how web application specs are currently getting written. They are getting crazy complicated, and CORS might have like the biggest security impact, but there's so many. So here's a screenshot from the CORS RFC. We didn't cover CORS because and in depth in this talk because it is 6 response headers and 3 HTTP request headers that are required to explain. And that is too complicated. Like, this is something that was made for developers, but they clearly were not thinking about developers when they created CORS and wrote this RFC. And so it should be way easier. They clearly thought about this problem in advance because they invented this star thing and said no cookies can be sent with star. But it's just, it kind of reminds me of OpenSSL, how it's just like tons and tons of badness all together. And CORS is not alone in this. These are like the new hot security headers that everybody's talking about. There's like securityheaders.io, and which gives you a grade based on security headers, which is ridiculous. And they have, like CSP is big one, content security policy, sub-resource integrity, HPKP, HTTP public key pinning, credential management isn't a header, and HSTS, strict transport security. And these are exciting, and I don't know why application security people really love this stuff, because it's like, this is for the castles, not the deflated bounce houses. Because it's hard enough to even get the basics done and prevent cross-site scripting and have a good way to mitigate CSRF. And so this kind of stuff is like, it's cool to talk about and it's cool that it exists, but it's kind of it's gotten really big and really complex, and for some reason everyone really wants to do it. And so content security policy, if you're not familiar, quick rundown. It's supposed to be 1 header, but it's still 3 headers, and some browsers don't support the 1 header. I'm not up to speed on who supports what, but it's a mess. And it's growing every day. And I really like learning about it, but it's just a pain to keep up with and do all the reading about it. So content security policy is a way to provide a policy by HTTP response header that dictates what resources can load from what origins and what paths. And so you can say, I want my fonts to only load from my site over HTTPS from the fonts directory, which is nice, but there's a ton of other stuff you can do that's all getting new and being added. And I personally love CSP because I put content security policy on the Cloudflare website, and now the marketing people have to come talk to me every time they want to add a new marketing integration. And so that is one great, I think, a great use for CSP. Yeah. So here's Mike West, who's one of the authors of CSP, and he works on it daily at Google. Super smart, crazy smart guy, and but it just goes to show, like, this is getting complicated when the guy who wrote it says it's complicated, and he's thinking maybe we should do something about this. Sub-resource integrity, I don't want to talk about. It's not a response header, so I'm cheating. HTTP public key pinning, this is one that I think there has been people kind of sanity checking. We have seen this, and people aren't super gung-ho about public key pinning because it's hard enough to keep a cert from expiring on your website, let alone keeping a HTTP response header in sync with the cert. So public key pinning is a is a HTTP response header where clients that get this response header will only trust a small set of public keys that are set in this response header. And so it's like trust on first use. You get this response header, and you're kind of stuck with those public keys until they expire. And this is an operational burden. There's been other talks about this. I forget the guy's name, but like people have thought about hostile pinning and all sorts of weird stuff with this. I just care about like breaking my own site, and it's hard enough. So public key pinning, if you mess up with it, your site could just be down for 6 months for everybody who went to it while you broke it. They would have to go in and clear their HTTP tab, and it would just be a nightmare. So I think you've seen people kind of push back on this one. And here is Ryan Sleevey. He also worked on this HPKP spec, and he kind of regrets it too. It kind of got out of hand. HPKP is it's scary. Credential management. This is one I like to talk about because not many people have heard about it. There's a web AppSec spec that is in your Chrome browser right now, where there's a JavaScript function that you can call that will request, basically your browser will do a login and take something that's stored in your Google Chrome password manager. When it says, would you like to save this password? They created a JavaScript API to call this function, and it'll log you in using that password. And like, nobody's heard of this, nobody's looking at it, and it's 20-page long spec of details about how it works, and it's super complicated, and I'm afraid of this thing. And so it's scary. And HSTS, strict transport security, it's a way of, once you access a HTTPS site, they return this HSTS header, and you're stuck on HTTPS. Your browser knows only HTTPS. And this is like well accepted as a good header. I think people have kind of come to terms that the web should be encrypted and TLS should be default. And so it's super normal to see, and Google kind of really wants you to include subdomains. They really want you to say, okay, uber.com is HTTPS only, but also demo.uber.com, m.uber.com, and all these other, every subdomain available. If you say include subdomains, then they're all HSTS in. And this is a screenshot from Google has a HSTS preload list, so your browser maintains this big JSON file of every site that it knows is HTTPS only. And Google, it's just a giant file with names in it. And here's Uber. They must have had some operational issue. They asked to be removed from the list after they had I don't know what happened, but they clearly did not want to support HSTS anymore for all their subdomains. So it's if Uber, who they may not be a castle yet because they just like sprung up and hired like thousands of people really quickly, but if Uber still has trouble with it, it's like maybe a lot of other people have trouble with HSTS too. It's not as easy as it looks. So what I'm preaching is usable security, and web AppSec specs need to become more usable. And the target for web app specs and all these RFCs that are getting pushed out needs to be developers. And anything, I guess, everything coming from AppSec people, developers consume it. And so I guess we just have to keep that in mind. It's also kind of strange that these RFCs are produced and it's like a contract where this thing is going to be supported for years and years and years to come by your browser, whether you like it or not. And so there should be more people looking at this. There should be more people who care and who speak up and say, this is a bad idea. But so yeah, who remembers OpenSSL? This reminds me of OpenSSL. And so I don't like it. So TLS 1.3, if I'm not a TLS person, but I think TLS 1.3 did something very notable that's worth mentioning. TLS has been plagued with all these security problems for years, but they get patched, but they're always noteworthy. And TLS 1.3 has been trying to take this into account as they formalize what TLS 1.3 will be. And they have tried, there's some bad things, I think, in TLS 1.3, but one very good thing is they've limited the set of cipher suites that are allowed. And so you don't have problems of people just picking horrible cipher suites. There's only a couple allowed, and you either support them or you don't. And I think that's a big step forward because if you gave people the opportunity to be insecure, they were taking the opportunity to be insecure with the way TLS was set up in previous versions. So I think that one thing is a really positive thing. And so I think it should be easier to make a castle. And so where do we go from here? Web specs are hard. I think they should be made easier, like a lot easier. And I think they need to be more developer focused. I think CORS needs a full rewrite because it's just too confusing. CSP is complicated. SRI, we didn't talk about that. I would love more people to be involved with the spec, the web app spec space, reading these things and understanding them and pushing back on and slowing their roll as they pump out these new RFPs by the quarter. It's usually like one a quarter or something. It's pretty rapid, I think. Yeah, so I'd like to make it easy. And thanks for coming to my talk. And if you would like to help make the web better, Cloudflare is looking for people to make it better. Because this stuff is really hard. Thank you. Oh, and does anybody have questions? Yeah, so CVE database I think is more well-suited for specific versions of software problems. And this is misconfiguration. And so it's not, I don't think it's well-suited. It's like, if you do this bad thing, then there will be a bad consequence. So yeah, and for the record, her question was, why don't I get a CVE for this? Yeah, I could look more into it, but I haven't. I don't like CVE database. Yeah, this should definitely be something that like every scanner looks for. Yeah, CWE would, yeah. Any other questions? Well, thank you guys.